The sum of first n terms of an AP. Theorem: the sum Sn of n terms of an AP with first term A and common difference D is Sn is equal to n by 2 into 2a plus n minus 1 into D. Sum of first n terms of an AP is Sn is equal to n by 2 into 2a plus n minus 1 into D. We need the proof of this. Let a1, a2, etc., an, etc. Let a1, a2, a3, etc., an be the first n terms of an AP. The first n terms of an AP. So what we need is the sum of first n terms, which we can represent as Sn, is equal to a1 plus a2 plus etc. plus an minus 1 plus an. The previous term of an is an minus 1, which we can write as a1 is clearly a. Sn is equal to a plus, a2 is a plus d, a plus d plus etc. plus the last term is a plus n minus 1 into d. So a plus n minus 1 d is the nth term. So a n minus 1th term is a plus n minus 2 d. This is the first equation. So we got Sn as a plus d plus etc. plus a plus n minus 2d plus a plus n minus 1d. Next, what we are going to write is, we are going to write this Sn in the reverse order. That means starting from here. So Sn is equal to a plus n minus 1 into d plus a plus n minus 2d plus etc. plus a plus d plus a. This is equation 2. Then what we are going to do is, we are going to add equation 1 plus 2. So left side clearly 2Sn. Then we are adding the first two terms. Here a plus n minus 1 into d, here a. So it is 2 times a, 2a plus it is 2a plus n minus 1 into d. That is the sum of first two. Next, sum of next two. Again a plus n minus 2, this is the first term, a plus n minus 1d, second term a plus n minus 2d. So what we have done is a plus n minus 1d plus a, so it is 2a plus n minus 1 into d. Second term is, we are adding here a plus n minus 2d plus a plus d. So a and a we can add, 2a plus n minus 2 plus 1d. So it is equal to 2a plus n minus 1d. So when you add the second term also, when we add both the second terms, we are getting the same answer, 2a plus n minus 1d. So if you add throughout, you will get the same answer. So Actually, we are adding n terms. It is n into 2a plus n minus 1 into d. So, 2Sn is equal to n into 2a plus n minus 1 into d. I will explain up to this again. We are going to prove the sum of first n terms of an AP is Sn, which is equal to n by 2 into 2a plus n minus 1 into d. So, we have taken let a1, a2, etc. an be the first n terms of an AP. Then what we need is Sn is equal to a1 plus a2 plus etc. plus a n minus 1 plus an. So, a1 means the first term a, a2 means a plus d plus etc. plus a n minus 1th term, a n minus 1 is a plus n minus 2d, a n is a plus n minus 1d, like this. Then this step we have written the reverse order. We have started from a plus n minus 1d plus a plus n minus 2d plus etc. plus a plus d plus a. And next we have added both these equations. So, left side become 2Sn. When you add each term a plus n minus 1d plus a is 2a plus n minus 1d. The second term a plus n minus 2d plus a plus d also will give the same answer. So, we are getting the same answer throughout. So, n terms are there. So, it is n into 2a plus n minus 1 into d. So, Sn is equal to, therefore, Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the final answer. So, what we got is Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula to find the sum of first n terms of an AP. Then as a note I am giving Sn is equal to n by 2 into 2a plus n minus 1 into d. And we can write this as n by 2 into a plus n minus 1 into d. I have written 2a as a plus a. So, what about this? A plus n minus 1 into d is a n itself, that is the nth term, n by 2 into a plus a n, which you can write as n by 2 into first term plus last term. Which you can write as n by 2 into a plus l. This is another formula to find the sum of first n terms of an AP. It is actually n by 2 into 2a plus n minus 1d. We have written 2a as a plus a. So, combining this a plus n minus 1d, we are getting this as a n, the last term. So, n by 2 into a plus a n. That means n by 2 into first term plus last term, which is equal to n by 2 into a plus l. This also can be used to find the sum of first n terms of an AP. Then example 11, find the sum of first 22 terms of an AP, a, 3, minus 2, etc. Find the sum of first 22 terms. So, we can take n as 22, AP a 3 minus 2. So, a is equal to 8 and d is equal to 3 minus 8, which is equal to minus 5. We have to find the sum of 22 terms. So, we can write Sn as n by 2 into 2a plus n minus 1 into d. Here the last term is not given. If it is given, it is easy to use n by 2 into a plus l. But it is not given, so we should go for this n by 2 into 2a plus n minus 1 into d. So, n is 22. 22 by 2 into 2 into 8 plus, so 21 into d. What is d? Minus 5. So it is equal to 11 into 16 minus 21 into 5, which is equal to 11 into 16 minus 105, which is equal to 11 into minus 89, which is equal to minus 979. This is the sum of first 22 terms of this given AP. Therefore, you have to write the final answer. S22 is equal to S22. Here also we have to write S22 is equal to minus 979. Just application of the formula. Example 12. If the sum of first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. If the sum of first 14 terms is 1050, S14 is given as 1050 and first term is given as 10, we have to find the 20th term, that means A20. Find A20. Start with S14. Sn is equal to n by 2 into 2a plus n minus 1 into d. So S14 is equal to 14 by 2 into a is 10, 20 plus 13 d. We need to find d. So it is given as 1050. So 1050 equal to 7 into 20 plus 13d. That is equal to 140 plus 91d is equal to 1050. So 91d is equal to 1050 minus 140, which is equal to 910. So it is d is equal to 910 divided by 91, which is equal to 10. So we got d. What you have to find is A20. A20 is equal to A20 is equal to A plus 19d. What is A here? A is 10. 10 plus d also 10. So 10 plus 190, which is equal to 200. So A20 is equal to 200. Then sixth question, example 13. How many terms of the AP 24, 21, 18, etc. must be taken so that their sum is 78? How many terms? How many terms means we should find n. How many terms of the AP 24, 21, 18, etc. must be taken so that the sum is 78. What is given as Sn is equal to 78 and A is equal to 24, D is equal to 21 minus 24, and we need to find n. What is n? So again we have to use the same formula, n by 2 into 2a plus n minus 1 into d is equal to 78. So n is not given, n by 2 into a is 24. So 2 into 24 plus n minus 1 into d, d is minus 3 is equal to 78. So it is equal to n by 2 into 48 plus n by 2 into 48 minus 3n plus 3 is equal to 78. N into 51 minus 3n is equal to 156. So, 51n minus 3n square is equal to 156. So, it is quadratic equation minus 3n square plus 51n is equal to 156. So, 3n square minus 51n is equal to minus 156. So, it is 3n square minus 51n plus 156 equal to 0. 3 is common, so we can divide. N square minus 17n plus 52 equal to 0. So, this is a quadratic equation. So, we can solve using any of the methods which you have learned, either by using factorization or by using the quadratic formula. Here I am using the factorization. So, we need two numbers in which p plus q is equal to minus 7 and p into q is equal to 52. This implies that p is equal to minus 13 and q is equal to minus 4. P is equal to minus 13 and q is equal to minus 4. So, we can write this as n square minus 13n minus 4n plus 52 equal to 0. So, it is n into n minus 13 minus 4 into n minus 13 equal to 0. So, n minus 13 is common. So, n minus 13 into n minus 4 equal to 0. This implies that n is equal to 13 or n is equal to 4. So, the number of terms can be either 13 or 4. The number of terms can be either 4 or 13. Next is example 14. Find the sum of first 1000 positive integers. Find the sum of first 1000 positive integers, and second question is the first n positive integers. So, positive integers means it is 1, 2, 3, etc. 1000. First term is given, last term is given, and we need to find the sum of this as 1000. It is equal to 1000 by 2 into first term plus last term, a plus l, which is equal to 500 into a is 1 and this is 1000. So, it is equal to 500 into 1001, which is equal to 500 and 500. So, next is the first n positive integers. N positive integers means 1, 2, 3, etc. n. So, n terms are there. So, Sn is equal to n by 2 into first term plus last term, which is equal to n by 2 into 1 plus n. So, it is equal to n into n plus 1 by 2. This we can take as a formula to find the sum of first n terms. So, write this. Sum of first n positive integers is equal to n into n plus 1 by 2. Sum of first n positive integers is equal to n into n plus 1 by 2, which you have to by heart.